simple movements. They can add complexity to any automation system, especially if you have a lot of them. Let me just show you how easy they can be. First step is we're going to create a new project. Accept a default name. It's not a problem. We're creating a project container now for all the hardware and software to go into. Next step is configure a new device, add new device. We're going to choose something called the unspecified S7-1200 CPU, click add. So now we're taking the project container and the hardware container and adding those two together for the project so we can start. Okay, so we have the actual hardware here in the white box. I have a little pop-up box. I can click detect. I'm going to go out and scan the network now, try to physically find that hardware, and we have. So I'm going to click on it at this point, and in fact I can click the flash LEDs to prove out that this is the correct hardware. This is the correct piece of hardware I want to detect. Click detect again. This time we're going to go out and scan Profinet, go find the exact CPU and all the associated I/O cards as well as communication cards and bring it back into the project so we can start programming immediately. The beautiful thing about this is I don't have to use the hardware catalog to pick and choose every single piece part. I can scan it, find it, bring in the project, go. Next step. What if we want to change an attribute of this hardware? Okay, let's do that. Let me right click on this analog card, click properties. Now you can see I have a plus or minus 10 volt for this analog card. I'm going to choose plus or minus 5 volt. I'm going to give focus to the CPU and I'm going to click download. So now I'm taking the physical hardware configuration, including attribute changes, and download to the actual hardware set so that he's an operational piece of hardware. It's compiling in the project. I click load. Now it's actually loading this to the actual CPU itself. And once it's finished loading, I can actually click the finish button, click start all, click finished, and now we should have a set of all green LEDs for this piece of hardware. Now, you remember I changed one of the attributes for the analog card. So that means I could actually turn this analog potentiometer and you see we actually have red LEDs across this. I went beyond the 5 volts. One thing you can do immediately is I can actually go online with the CPU, give focus to it, click the online button. Now that we have orange bars across all the physical software, you can actually tell that we have been online with this hardware set, and you can see all the red wrenches here. I can actually go down to the module level and I can see that there's something going on with this analog card. At this point I can double click on online and diagnostics and go to the diagnostic buffer, and as you can see we have a high limit exceeded with the wrench for the actual output of this analog card. So if I go back and solve the problem, turn the switch back, now it's an outgoing message and the issue is solved. Basically this means we have the ability to create online diagnostics for your hardware set, and you didn't have to do a single thing to do that. You didn't have to program for it, you didn't have to choose any menus, it automatically will give it to you right out of the box. So let's go back offline with this CPU and close this screen, back to the hardware set. How about programming? Let's go ahead and start that right now. First step, the main OB. You can see, if I go here and start flipping dip switches, I have absolutely no program in this particular CPU at this point. It's just a hardware configuration. Let's go choose a normally open contact, a normally closed contact, a coil, another normally open contact. Let's tie those together. So now I've actually literally built a seal-in circuit used time and time again in automation engineering. How about the tags? Let's go start programming that real quick. Let's say start for the first one, motor 1 for the next one, stop, and then for a coil, motor 1. Whoop. So our seal-in circuit's done, our tags are done, however they're not tied to the hardware set yet. So next thing I can do is do a split screen, give focus to the CPU, go to 400%, and as you can physically see here, the hardware set has the associated bits of the actual points. Well, guess what? I can drag and drop that start directly to that point. There's the start, there's the stop, there's the motor 1. Our code is now complete. I did in just a matter of seconds. I can drag and drop between multiple editors That's engineering efficiency. Next thing I could do is actually download this quick program to the CPU, give focus to it, click the download arrow button. Now it's compiling in the background. Click the load button. Now it's actually going to load it to the CPU, and then click finished. And once this LED goes green, you can see that my standard sealing circuit is complete. Okay, we've done our standard sealing circuit. How about user-defined function blocks? We have the ability from a global library standpoint to create anything you want to from a programmatic standpoint, add it to the library, and reuse it over and over and over again. That way you can create engineering efficiencies in your daily work. Let's do exactly that. Let me close this. Let me click on libraries, drop this down, and you can see I have something called the AT1 simple movements. There's a wiper control block here. Let me drag this into the project. I'm just going to accept the default data block, no problem. Next thing we can also do is not only can I take a function block, the potential associated tags, you can reuse those over and over again, save those to the global library as well. Let me go grab the wiper control tags, pull it into PLC tags. Now we have the tags and the block. All I can do is associate them together, and we can move forward. There's the right wiper. There's the left wiper. Here's the counterclockwise as well as run wiper. Next thing we can do within the same editor, I can go grab the actual coil from the sealing contact, hit Control, drag that down to the start, and I can actually use interoperability between lines of code in a single editor. Our code is complete. If I give focus back to the CPU, click the download arrow button, it's going to compile this in the background. Once it's finished compiling, I can click load. Now it's actually going to load that code to the CPU. Click finished. And at this point, I have a fully functional wiper control system, and I did it in less than 10 minutes. Now that's engineering efficiency.